Hey, welcome to Zona Mechanica. Hope you are enjoying our videos. If it is really helpful to you, please do share with your friends. If you are new to our channel, please do subscribe it. There is an MCQ on bolted joint. Actually, there are two questions based on common data, and these two questions are linked answer type of question. That is, the answer of question number 2 will be used in the solution of question number 3. Figure at the margin indicates the weightage of the question, that is 2 marks. So as you can see in this figure, there is a cantilevered bar, okay, and it is fixed with the help of two bolts P and Q, okay, and a load of 4 kilonewton is working here. The distances given over here. Well, so question number 3 is, what is the resultant shear stress on bolt P? Okay, so the resultant shear stress on bolt P we have to calculate. Well, first let us see what we got in question number 2. In question number 2, the question was, what are the primary and secondary shear stresses acting on bolt P? And we got two results. Primary shear stress as 2 kilonewton and secondary shear stress as 20 kilonewton. Okay, so for the resultant shear stress, we need to know the resultant shear load. Okay, what is the resultant load working over here? Okay, so that is PR. Let us see how the primary shear load and secondary shear load is acting over here. See, the load is working vertically downward, so the primary shear load will be working vertically downward in both the bolts. But the secondary shear load is occurring due to the moment developed due to this force, okay, over here. That is the force into this distance, okay. So the clockwise moment will be generated, and due to that moment the secondary shear will be acting. See, in bolt P, the secondary shear will act upwards, and in bolt Q it will work downwards. That is, both the primary and secondary will work in the bolt Q downwards. Okay, whatever it is, we are concerned about bolt P. So this is 2 kilonewton, okay, primary shear load, and this is the secondary shear load, 20 kilonewton. Okay, so these two are opposite in direction, so the resultant shearing load will be 20 minus 2 kilonewton, right, which is equal to 18 kilonewton. Okay, and since the bolt is M12 bolt, so the diameter, that is the nominal diameter or shank diameter of the bolt, is 12 mm. So now the resultant shear stress, okay, will be the resultant load divided by the cross sectional area of the bolt, right. See, this bolt, both the loads are shearing to the bolt. Since the bolt is horizontal and the loads are vertical, so both the loads are shearing in nature. Okay, so this is the shearing load, and this is the cross sectional area. Okay, so 18 kilonewton, that is 18 into 10 to the power 3 newton, divided by pi by 4 into d square. So what is d square? 12 mm square. So this much of Newton per square millimeters, right? So this will give 159.15. This is Newton per mm square, which is equivalent to MPa. Okay. So this is the resultant shearing stress on the bolt P. Okay. So clearly it's matching with option B, 159. Okay. So option B is the correct answer.